If I could begin to be, let's go. Longest increasing subsequence. It's Ferrari DP. I forgot DP. Longest increasing subsequence. Given integer array norms, return the length of the longest strictly increased subsequence. A subsequence is a sequence that can be derived from the given sequence by deleting some or no elements without changing the relative order of the remaining characters. So, for example, cat is a subsequence of cat because you can remove R and B. I do not know how to do this now. Num equals 9. Okay. So, if you remove, wait, does it have to be, okay, it has to be increasing. So, when I remove 4, we need the 1, 2, 3, 3, 7. That's the length. So, we're gonna have to track the length of the, ano, if it is a subsequence. So, if this is DP, then we should use DP, right? So we should use a DP array, but how? Okay. Oh, should name first square better than O of n square time and O of n square space, where n is the size of the input array. Give me hint. I guess, to be honest, I don't really want to do DP. Like, how would I, what if I just try to solve it with my own way? I mean, I think I know how to do this, so. Good morning, everyone. Tonight we're going the action. I, present po. So the sequence is increasing represent choices by adding one, by including an element and zero and excluding version. How can I ensure current element is greater than the previous one? Perhaps additional information is needed to process it. Because store the index of the J, provision stores an element as J, making it easier to process the current element of the index if and only if J is equals to -1, or nums or the number at index I is greater than numbers of index J. So if number at index I is greater than not, so do we like Can you determine the concentration and most to represent of each recursion set? Start the recursion index I goes out of bounds and return zeros as normal elements can. The additional recursion call starts with j equals -1. At each step, include the current element. If it's greater than the previous point, continue the recursion. Or we explore it and explore the next possibility. Return the maximum value obtained from both paths. Like, I'm sure we're gonna use a max between max. That's equals max between S and inside. Max. Max stress. He knows that max stress. Can use memorization to store the results of recursive calls and avoid recalculations. A hash operator to the array can be used to cache these results. So is this DFS? Okay, it's DFS. I like, oh hell no.
Hey everyone, welcome back. Let's solve another problem today, longest increasing subsequence. And this is another tricky dynamic programming problem. And I'm going to show you how to go from the recursive solution to the dynamic programming solution. So we're given an array of numbers and we just want to return the length of the longest increasing subsequence. And if you don't know what a subsequence is, it's basically like, let's say this is our input array. We're basically taking a subarray, but that subarray does not have to be contiguous. So like we have from here, so subsequence is 3, 6, 2, 7. Basically, we took this subarray and we removed 1, 2 from it, and we removed a 1 from it. And now it's 3, 6, 2, 7. But you notice about this subsequence, it's not in increasing order, right? We have 6 and then we have 2. That's not increasing order, so this is not a increasing subsequence. So in this example, we're given about 9 elements and we want the longest increasing subsequence, which we see is this. And so how did we get that subsequence? Well, you go from 2 all the way to 101, but you notice that unfortunately this is not in increasing order. We have a 5 and then we get a 3 right after. So
Uh, I guess I can go for starting see, copy, copy, control, 0, starting from conference, conference, control. Wait, no, stop. I forgot, bro. Land of Knobs. About anything after the
we actually
day start from -1 all the way to -1. So we're iterating over. Yeah, you can do that, but I want to do it on my own one. Fine range, zero, Yeah, let's J greater than bounds up. It's I on N up to one. Oh, yeah. Just- Yeah, but I think this requires DFS. This one keep going without following the J. Yeah, stuff. Just as to, oh, that one. Oh, such a dumb solution.
Actually have two choices. If we remove the 3, we have an increasing subsequence. If we remove the 5, we also have an increasing subsequence. But we just care about the length, which in this case is 4, so we return 4. So the first idea you might have is brute force using depth first search. So let's say that this is our input array, so we have 6 elements. For if we want to know the brute force, meaning we want to generate every possible subsequence, we have a choice for each value, right? So for the first 0, we have a choice. Are we going to include this 0 in our subsequence, or are we not going to include it in our subsequence? So in reality, for each value, we have two choices. Now, when we get to the next value, we also have a choice. Are we including it or not? So again, we have two choices if we want to generate every possible subsequence. So we do that for every single value, and then we see that there are actually 2 to the power of n possible subsequences, where n is the number of values given in our input array. So already you can see the time complexity is not going to be great, but can we take this brute force approach and then somehow modify it to get a better solution like n squared? So let's look at another example, and this time we're going to do depth first search with caching, and we're going to see how that improves our time complexity. So we have an example of 4 elements, so it's kind of obvious that this is our longest increasing subsequence, so the result result is going to be three elements. But how can we do this with an algorithm that's efficient? Well, let's start out with the brute force approach. Let's check all subsequences starting at index 0 and then repeat that starting at index 1, starting at index 2, and starting at index 3, right? So these are the indices. So we take one decision to start at index 0. We take one decision to start at index 1, one decision to start at index 2, and one decision to start at index 3. So in these cases, these are going to be the subsequences we have so far. So we know index 0 has value 1, index 1 has value 2, index 2 has value 4, index 3 has value 3. So now let's go along the first path, so index 0. So we know if we start at index 0, we have 3 values that come after it. So we can try all 3 of these possible decisions. So we can go along index 1, index 2, and index 3. And we see that all 3 are possibly valid because all 3 of these values are greater than 1. So we can continue these subsequences. So we know index 1 has value 2, index 2 has value 4, so we can add a 4. Index 3 has value 3, so we can add a 3 to our subsequence that originally was just 1. So now we took index 0 and index 1. So for here, we only have 2 indices that come after these 2 values, so let's continue our decisions. We see that both 4 and 3 are greater than the last value in our subsequence, which is 2, so we can choose both of these decisions. So if we take index 2, then we can add a 4 to our subsequence. If we take index 3, we can add a 3 to our subsequence. So now let's continue here. We have 3 values so far in our subsequence, and there's one index that comes after 2, index 3. It has a value 3. So can we add a 3 to our subsequence? We'll get 1, 2, 4, and then 3, but this 3 is not greater than the last value in our subsequence, so we technically cannot make this decision, so we cannot continue to increase this subsequence anymore. So we can mark this as reaching its limit. We cannot continue it anymore. What about this one? Well, it stopped at index 3, which was over here. So are there any elements that come after it now? No, there's not any elements. So this subsequence has also reached its limit. So we cannot increase it anymore. But so now let's focus on this caching part. What kind of repeated work have we eliminated? Well, let's just do this out of order. Instead of doing these first, let me show you what happens if we try to extend the 3 now. We try to get another element, right? We started at index 3, but we know that no values come after index 3, so this one cannot be continued. But what do we know about index 3? If we start at index 3 and we want the longest increasing subsequence, we just get a single 3. So that tells us that LIS starting at index 3 is 1. We don't need to repeat this work. And isn't that what we just learned over here? Even though this subsequence is length 3, we are talking about starting at the 3, and we noticed we could add a 3 to it, right? This was the element that we added, but as soon as we added that 3, we could not increase this subsequence anymore, right? That's what this X tells us. We were only able to add one element if we start at index 3. And that's exactly what this 2 told us as well. If we start at index 2, we can add a 4, but this 3 that comes after it cannot be added. We cannot include that, and there aren't any more elements to add. So as soon as we finished this and we found this X, meaning we could not go any lower, we knew that the longest increasing subsequence starting at index 2 is also 1. So therefore, if we start at index 2, we cannot go any lower. We cannot continue this. And we don't even have to attempt to do that. And what about this branch? So if we started at index 1, we would start with the subsequence of 2, right? That's what this tells us. And so now I'm going to do some more stuff, right? I'm going to choose the next indices 2 and 3. But wait a minute, do I actually have to do that? Because
Water. Sige, okay lang.
look over here. We started with index 1 and we already did that. So when we started with index 1, we saw we had two choices, a 2 or a 3 index, right? We could choose this or we could choose that. We saw both of them ended, right? We could not continue either of them. So if you want the longest increasing subsequence that starts at index 1 over here, no matter what you choose, the subsequence is going to be length 2 either way, right? Because if we start with a 2, then we can add a 4, or we can add a 3. But we cannot add both of them. So we can mark the longest increasing subsequence starting at index 1 to be length 2. So we actually don't even have to go down this path once we already go down here, because it's just going to be repeated work. And we also see for these two trees that we have not finished yet, once we add a 4, the longest increasing subsequence at index 2, which is where 4 is at, is going to be 1, so we cannot continue this anymore. Similarly, once we add a 3, we know no values come after it. The longest increasing subsequence starting at index 3 is just 1. We cannot increase this anymore. So when we finally, in our depth first search, get back to the root, we're going to see that the longest path is one of these, right? Either that, or of course you could go down this direction, but either way, the longest increasing subsequence starting at index 0 is going to be 3. And so when you look at these 4, right, because these are our subsequences. These are the longest subsequences starting at each index. The greatest one is 3. And so therefore the result is 3. But now if you actually want to do the dynamic programming solution, you might notice how we're doing this recursively. We're kind of starting at the last index, right, 3, and then working our way up backwards to 0, so then going back here. So can we use that to do dynamic programming? So now let me show you the dynamic programming solution, and it's actually easier than you might think. So we're gonna start at the last index 3 and then work our way backward. So we know this is kind of the base case, right? No values come after it. So the longest increasing subsequence we could make from here is just gonna be length 1 anyway. So we can say the LIS starting at index 3 is just 1. That's the max length. Now, how do we get the longest increasing subsequence starting at index 2, which is just 1 shifted to the left? Well, one possibility is just 4 by itself, right? So that's one possibility. It could just be 1, or it could be 1 plus the longest increasing subsequence starting at position 3. And what this means is if we take both of these, right? Because LIS of 3 is just 1, right? So 3 by itself. But we're only allowed to do this if the value nums at index 2, which we know is 4, is less than nums at index 3, which we know is 3. Is this true? This is not true. So we are not allowed to do this. So normally we would take the max of these two values, but we know that the condition to take the max of this does not satisfy, so we only have one choice, 1. So the LIS of this is going to be 1. I'll put it over here like in the corner. So again, we're going to work our way backwards. So let's get the longest increasing subsequence, one index back at index 1. So we're going to do the similar thing that we just did. So we know we could take a subsequence 2 by itself, right? That's one choice. 1 is a choice, length 1. We also have a choice, 1 plus the longest increasing subsequence starting at 4, and we're allowed to do this because 2 is less than 4, so it is increasing. The subsequence is increasing. So another choice is 1 plus LIS of 2, and another choice is LIS starting at index 3 because 2 is less than 3, right? 2 is less than 3, so the subsequence is in increasing order. So 1 plus LIS of 3. Now we know that this is 2 and this is 2, so it doesn't really matter which one we do. The LIS of 1 is going to be equal to 2 regardless. So now we want the longest increasing subsequence starting at index 0, and we're just going to repeat what we just did. So we could take 1 by itself, which is just 1, or we could take 1, add it with the longest increasing subsequence starting at 2, or this longest increasing subsequence starting at this index or this index. So we know we're going to get 1 plus 1 from here. We're going to get 1 plus 1 from here. And we're going to get 1 plus 2 from here. And we're allowed to do all of these because you notice 2 is greater than 1, 4 is greater than 1, and 3 is greater than 1. So they are in increasing order. So then we know that the longest increasing subsequence of this is going to be equal to 3, which is what we want. So this is a much better solution. The dynamic programming solution is much better than brute force because the time complexity is O of n squared. But why is it O of n squared? Well, you see we're working backwards. We start at 3 and then we check every position afterwards, which is not too bad, right? So then we iterate through basically every value here. When we start at 4, we have to look at every value that comes after it. There's only one value that's good for us. So we iterate through these two values. When we start at 2, we have to check these subsequences starting at these two values. So then we have to end up iterating through 2 and every value that comes after, and we do the same thing for 1. So we iterate through 1 and every value that comes after. So you can tell by looking at this pattern is similar to an n squared pattern. So now let's finally write the code. So we know we're going to do this dynamic programming style. So let's have a cache or a list. It's initially going to be set to 1. Every value is going to be set to 1. It's going to be the length of the input array that we're given. So every longest increasing subsequence starting at every value or every index is initially just set to 1. We're going to try to find what the max is. So we want to iterate through every index in the range of our input array, and we want to do it in reverse order. So that's what I'm going to do in Python. If you're not familiar with Python, this might look a little weird, but basically what I'm doing is starting at the last index and then going all the way to 0. And just like I showed in the example, we're going to start at index I, like this could be I, and then we want to iterate through every subsequence that came after it. So I'm going to have another nested loop for j in range. So starting at I plus 1 and then going to the end of the input array. And before we can update LIS, we want to know, is the value at I actually less than the value at j, because j comes after it. If we want this to be an increasing subsequence, this condition has to be true. And only then are we allowed to update the longest increasing subsequence at index I. And we can set it to the max of itself and or the max of 1 plus the LIS starting at j, because we know for sure j is going to be in increasing order with I. And literally that is it. We made sure to evaluate that it's an increasing order. We did it backwards. We made sure to cache the repeated work. What do we have left to do? Well, we want to return what the max is. How can we do that? Well, in Python, you can just take the max of a list. So whatever whatever the greatest value is in here is going to be returned. And there actually, so this is O of n squared, and there actually is a better solution, big O of n log n, but I really doubt your interviewer is going to expect you to get this on your own without a hint. If they do, I would personally just walk out of the room. But I hope this was helpful. If you enjoyed, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. And there actually is a better solution, big O of n log n, but I really doubt your interviewer is going to expect you to get this on your own without a hint. If they do, I would personally just walk out of the room without a hint. And there actually is a better solution, big O of n log n, but I really doubt your interviewer is going to expect you to get this on your own without a hint. If they do, I would personally just walk out of the room. But I hope this was helpful. If you enjoyed, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon. starting. Hey everyone, welcome back. Let's solve another problem today, longest increasing subsequence. And this is another tricky dynamic programming problem. And I'm going to show you how to go from the recursive solution to the dynamic programming solution. So we're given to the max of it, and there actually is a better solution, big 2, or this longest increasing subsequence starting. So normal choice way of n squared. 2 n set to 1 and shifted to the left. Well, 1 plus, essentially we would take the index 1, I'll put it over here like in the corner. So again, we're going to work our way backwards. So let's get the longest subsequent twice. Also have a choice 1 plus the longest increasing subsequence starting at 4. And we're allowed to do this because 2 is less than 4. So it is increasing. The subsequence is increasing. So another choice is 1 plus LIS of 2. And another choice is LIS starting at index 3 because 2 is less than 3, right? 2, 2, 2 regardless. So now we want the long